Hello, everyone. My name is Rich Martin, Director of Technical Marketing here at Itential, and thank you for joining today's webinar, where we will cover automating data gathering processes from both CLI and API sources. So let's talk just a moment about that before we get into the demo. Why is it important to take a look at automating the data gathering process? So if you look at a normal process for something simple like deploying a change, and we're gonna speak in generalities here. A lot of effort is focused on automating the deploy changes, or even for our customers when they recognize our ability to automate outside of just networking with the different IT systems in their ecosystem. Things like how do we automate, ServiceNow tickets, updates, opens, closes, things like that. But really, a large part of that process is around gathering data. And it extends not just to gathering data that's useful for, or actually not just useful, that's necessary for deploying a network change, but it's also part of the process that we look into pre and post check tasks. So before I make the change, I need to gather some data about the network, and after I make the change, and then afterwards we have to also take a look at the network and make sure the changes are correct. And so if you don't automate this, the manual methods of gathering data that you're probably doing today, if you're not automating the data gathering process, is swivel chairing between different applications, using your text editor, because from that application you're going to extract some data manually from the web page or the website dashboard. You're going to copy, you're going to paste it, and then you're going to use your text editor as kind of your tool to now manipulate that data. And if you look at the entire process, even of something simple like making like a single network change to a single device, all of this data gathering process that exists from the very beginning and part of the pre and post check processes, those tasks take up a huge amount of time, and the potential for introducing error even through copy and paste, because you're still doing some form of editing in a text editor of some sort. So what I want everybody to think about in terms of gathering data in this entire process and how do we automate it is, you start with thinking about, where is the information I need for this network change? Again, we focus on the network change, but we need to know, where does this information need that's necessary for, or where does it exist for this network change? And then how do I access this information? Does this information come from a network device that's driven by CLI, or does this information come from a system which is accessible not just through the dashboard or the console from a web interface, but through backend through an API call? And then how do I use this and process and manipulate this data? So once I capture the data, think through your text editor. I paste it in. Now I've got to change the data so it's useful for perhaps generating CLI commands, copying, paste that into a network device, or any number of tasks or steps afterwards. So in the demo, that's what we're going to take a look at. We're going to go into detail and start building upon how to use this data gathering processes in our platform, how to automate this. So we're going to gather data using API methods from an onboarded NetBox integration. So we can do an API call. So this is where we can gather data using APIs to systems, but they can also be APIs into network controllers as well. The idea here is that you're probably going to need to gather data from sources that are API managed, and you're probably going to need to gather data from sources that are CLI managed, like to individual network devices or network elements. So for that, for the CLI side, I'm going to show you command templates. We've done a lot of previous episodes of our webinar series around command templates. So I think this is a very powerful way of gathering data and using that data. This is something that's really, really useful, especially if you're a network engineer with not a lot of background into building automations. It gets you started real fast. So I really want to show you how you can leverage that, and it does save a lot of time. And then we're going to be able to extract that. So it's getting the data. Now, how do we extract and manipulate that data? And we will use something we call data transformations in our product, so that we can show you how to leverage structured data in an API call and a data transformation, and even through a command template as well could be used that way. And then you'll see how we can now use that data to implement tests and multi-layer pre-checks and post-check tasks in a full end-to-end automation. So with that, let me share my screen and we can go to the demo. Okay, so I am in our product, the Itential Automation Platform. I am in the area of the platform called the Automation Studio. So this is where we build automations in our canvas, a drag and drop canvas here. And what I've done, the first thing I want to point out to you is I've already kind of stubbed out a end-to-end automation task, and I've kind of staggered where everything is so we can show it. So a stub task. So for every one of these tasks, these green steps here, and some of the tasks will be different colored because they could be operations. And as we fill this out, we'll show you those different colors and those different functions. But generally speaking, this is a great idea to get started in our platform. So you can use something called a stub task. So every element or task or step on our canvas comes from this right-hand side. This is our task palette. And part of the task palette, one of the functions that we can use is a stub task. A stub task you can think of as a placeholder. So this is kind of like that whiteboard idea. What do I need to do? What is the process before I have to, zero in on any particular specific task? I want to maybe stub this out and kind of whiteboard it on here. And then we can start replacing tasks one at a time. And that's what I want to do. So I've stubbed this out into different sections and I've staggered them so we can kind of get an idea of what we're doing and tackle it one piece at a time. The first thing I want to draw your attention to is this deploy change. Ironically, we're not going to make a network change today. We've done plenty of that, and that's ironically also what everybody focuses on. What we want to focus on is getting the data together so that we can make the network change and make it safely. And that's what data gathering is about. Eliminating the swivel chair and being able to extract information from all of your available IT systems or any network device so that you have all that data available, and then extracting it and making it useful in a format for the automation. So the deploy network change is where a lot of folks focus on. That's great. And not only can we do this, and we have shown what the different methods we can do this, but for today's example, we're just going to focus really on this data gathering piece. So the first part here is, let's assume that our deploy change is going to be a simple thing. We're going to bring up a new interface on a Cisco router. So in order to do that, we need a certain set of information. Remember, the first question is, what information do I need? Well, I need to know the name or the IP address of the router. I need to know the interface and an IP address, right? That's a great example of multiple pieces of information that are required for a single change. Now, in the case of this example, in this demonstration, I'm going to limit it to just one piece of information, but I want you to think about that information could exist from multiple sources in the network, right? Your IP address could be coming from, your IPAM system like NetBox or Infoblox. Your device names might be available on some sort of inventory system, right? Or you may have CMDB or something like that holds information that you need. So while we're focusing on one system here, the idea is that you can integrate with any of those systems that hold that necessary data, and then use the same process of an API call into that system and a transformation to extract that data. So while we're only showing one here, you could extrapolate this to as many systems, API or CLI based, and then using all of that data in a transformation to extract and manipulate that data as necessary for subsequent tasks in your automation. So that's what we'll do here. We'll do an API call here in this section into NetBox. We'll grab an IP address, and then we'll build a transformation, or I'll show you how to leverage a transformation to extract that IP. But then we also, so that's necessary in order to make a change. What about making a change safely? So we need to do a series of pre-checks, right? So where does that data come from? Well, in a lot of cases, especially if I'm making a change to a network device that's CLI driven, then I probably want to access that device and maybe take a look at some of the network state or the state of that particular network device to ensure that before I make a change, it's safe to make that change. So in the case of bringing up a new interface, once I get the IP address and I have the other information I need, the router and the interface and the IP, and then what I need to do is to maybe take a look at that interface. So this is where you get a chance as a network engineer to think, okay, what is the normal procedure that I need to follow before I would bring up a new interface? Maybe I look at the interface, right, and see if it's up or down. And that's what we'll do here. And so what you're doing now is you're gathering data from a network device that's driven by CLI, and now we need to evaluate that data to ensure that everything is correct as far as the state so that we can make a change to that network device. And then the post check is similar. After we've made the change, we expect the state of the router to be different now, right? It should reflect the changes that we've made in this step. And so now we can do another series or of checks if we needed to, um, in order to determine that the state is now correct based off of what we expect. And again, this is exactly what people are doing every single day. Maybe they're not automating this process, but they're swivel chairing between, their inventory systems, their databases, their IPAM systems, grabbing this information through a dashboard, copying it, pasting it into, a text editor. Then they're SSHing into a system to take a look at that they're about to make a change on. They're looking at the system state. They're executing CLI commands, extracting the data that comes back from that CLI command. So that's what we're going to do here and parsing it. So that's how we can automate this process. So let's start first with making some changes. So we started with the stub. Now I'm gonna go here to another. It's the exact same web flow here, workflow, but now we can start make changes on this one. So the first thing I want to do is replace this particular task. So again, a stub task is just a placeholder. It allows us to run a workflow, but it really does nothing. It just sits as a placeholder. But now we can start to recognize and replace what we need to do. So if I'm going to grab an IP address, so if I've deployed NetBox, right, and I'm familiar as a network engineer using NetBox from the command line, I'm not the command line, from the dashboard, right, from the console that I log in through the website, I know that I can go to a particular page on there and determine like the prefix that I want to use, and then request another IP address, and it would give me that IP address, the next in the series, and then I can copy and paste that into a set of CLI commands that I can now deploy on a device. I want to automate that. So it's helpful to understand how your NetBox system works. And really, this is an opportunity to also go in and look at the NetBox documentation, especially around the APIs. And NetBox has a very, very good set of API documentations so that you can read and understand which calls that are necessary. So when you click that button to say, give me a new IP address, it's actually doing an API call, or there's a similar API call on the back end that provides the data that it needs to return an IP address for a particular prefix or a particular subnet that's been defined. So a little bit of work needs to be done to understand that. We won't get into all the details, but that's where you become knowledgeable about which API calls to use in the system. So when you onboard an adapter into our system, all of those API calls are available. So let me show you from a NetBox perspective what we have. So again, all of our tasks on here come from this task palette. I can go and open up NetBox and I can see there are a ton of calls. But because I'm used to doing this, I've read the documentation and I understand kind of the structure of these calls, then I can actually go right to the call that I need in order to replace this get next IP address. And that's going to be called post IPAM prefixes ID available IPs. So this is the actual API call that we're going to use to replace the stub task. So what I can do now, the first thing I want to do is I'll remove the stub task and I'll create the transitions to insert it into the workflow. So now I'll double click it and it's going to show me all of the information that's required in order to successfully run this API call into NetBox so that we can return the data that will provide us the next IP address for a particular prefix. So I'm just going to change this to get IP address. Same here to make it simple. Now I can have multiple, so since this adapter is on board in the system, I can actually have multiple NetBox systems that are accessible through the adapter. So now I can choose which NetBox installation I want to query. In this case, I'm going to use our lab NetBox. And so it's going to ask me for a variable here, which is an ID. This is the ID number again. So this is helpful to know the documentation. What this is asking for, this is NetBox saying, hey, what is the ID for the IP address, for the prefix that's been defined that you want an IP address for. So we've set up a demo one at ID 40. You get this information from NetBox directly. You can go into the NetBox system, look at a prefix, and then it will show you the ID. Or there are other tasks that you can call to query it, even if you're testing, to query for a list of all the addresses. So you could actually find this from within, as you're building workflows as well if you wanted to. The next piece of this that it's going to ask for is, remember, when it allocates an IP address, there's a lot of fields that are available, and we'll see a lot of those fields as we continue this. So one of the things that's nice to do is one of the fields is called a description. Again, this is when NetBox allocates an IP address, it's got a bunch of fields that you can set. It's always nice to say, hey, this is for a webinar test, so we can go and clean that out later. So I'm just going to set the description for the next IP address that we're requesting to be webinar test. And these are the two pieces of information that are required. It needs an ID, which is the type number, which I've given it as a static. So I've statically assigned this. And the data is an object. So I've formatted this as a JSON object, right, with one key, we'll call description, and the value webinar test. And again, this comes from the documentation for NetBox. So whatever system you're integrating to via APIs, it's going to have some requirements. It's going to give you a list in the documentation of the API tasks, and for each API task that you identify that you want to use, it's going to have a number of variables that might be required to be set. Some could be optional. So this is for requesting an IP from NetBox. So if I save this now, we can actually run this as a test and see what we get back. So I can run this from here. I can hit start. Let's view our job. And we could take a look at the results. So I'll zoom in a little bit here so we take a look at this. So what we really did was we only changed this step right here. We went from a stub task, which did nothing, to an actual, just a placeholder, to actually getting an IP address. So if I click on this, you'll see that the data that I just filled out for that task when I was building the workflow, now that we're running it, this is kind of in our job manager, so I can actually see this running. We can see that in the workflow, I set this statically to 40, and I gave it a description of webinar task. So that's the incoming data. So this is data coming in, was statically assigned. Now, what about the outgoing data? So that data is necessary to make the API call. Now we made the API call, and we can look at the outgoing data. So this is the data from NetBox. So this is coming back and saying this was successful, and you'll notice here, it's given us a lot of information here. Most of this information is not necessary for what we want to do, but we do need to extract some information, and that's what we want to get to here. We want this line right here, which is actually providing the next available IP address. So that could be used and will be used later in our workflow as we start to fill it out. But for right now, we need to take this step of removing it or extracting it, and we're going to use a transformation to do that. So if I go here, I'm going to copy this because this is going to be very helpful, and this is really how you can quickly build these automations in our platform. So if I copy this output, because this output from this API call is now going to become the input for our transformation task. And a transformation task allows us to extract information and even manipulate the data a bit so that it can be used in another task in our workflow. So now let's go back to here. So we've done this, right? We've leveraged an API call to gather data. We're gathering one piece of data, which is the IP address, the next available IP address. So now we need to extract that because it also comes with a lot of other information, and now we need to extract that. So we're going to use a transformation here. So I've built this transformation. So you create the transformation from Automation Studio again. I can create a transformation, and once I've created a transformation, they exist here in this list of other transformations, which means they're also reusable. So once I create a transformation, I can reuse this in other workflows as well. So that's one key component of this, is what we're building today doesn't have to be rebuilt every single time. We can actually, I'll show you in a moment how you can kind of modularize these and reuse these over and over. So transformations and even workflows themselves can be used as child workflows and reused. So you'll notice here that I have this object, this JSON object defined. So where did that come from? That literally came from what I just showed you when we ran this job. Remember, the output of this is going to be the input of this. So I want this format captured. So this is why I copied this information. So now if I go back into my transformation here, I'll show you what I did to generate this. I can go in here and paste that information. So this is the data that was returned from the API call to NetBox. So this is the actual response, and I can create a schema from that. So what we've done is we've allowed you to one click take real live output from one system and then create a formatted JSON schema so that we know from this transformations perspective what to expect. And since I've pasted the same schema in there, it's still preserving all these other steps here. So we'll get to that now. So notice in the schema, the one thing I'm really interested in to extract this data out is this address. But remember, the address comes out a little bit of a different format. So if I go back to Operations Manager where we actually ran this, and I look at the address, it comes back with the /24. And I really want to extract not only the data, but then I want to go into this string and I just want to remove the /24 because we don't really need that for this. So in our transformation, that's where we do that. So that, again, this is analogous to you parsing data from executing a command line, copying it into your text, your text editor, and then making the manipulations, or limiting what you copy and paste, and pasting it in. So that's what we'll do here. So we take this address, knowing it's going to be a new IP address with a /24, returned from the NetBox API call, and I'm going to use a function, or a method called split here. So where does that come from? That comes from the right-hand side. So very similar. Here's a palette of methods and functions that you can choose from and drag and drop into this canvas. So since this is a string, you see this address is a string, I want to manipulate that string. So what I'm using here is something called split. So this allows you to take a string and split it based off of a particular character in the string. And if you want help, there's plenty of help here. You can click on this and it'll give you pretty deep information on how to use this. But what this essentially does, it says, give me the string as the source, and then give me the separator character, which is the /, and then it's going to return basically an array of strings that it's split. So in this case, it'll be the IP address, it's split on the /, and then the the CIDR net mask /24. And so now I'm using another method here. So this, because this returns an array or a multiple string elements, I use the array method. And here I tell it to get the index. So that comes from right here. So what does that do? It allows me to specify a particular entry in this array. In this case, it's the first entry, which is index 0, because that's where the IP address is going to be held. So once I get that, now I can map it out to the outgoing data. So when this transformation runs, it's going to extract the address, it's going to extract just the IP address and not the net mask, and it's going to return it as a string called IP, so that it can be used in the command template, which is a subsequent step from here. So similar to that, we also need some other information, right? So if I'm going to make a change on a network, on a Cisco device, I also need to know which interface we're going to use. So instead of, just to keep it simple, again, this information could have come from another system, right? And we could have done an API call to another system to identify a router and then a particular interface to use, maybe the next available loopback interface. I'm statically assigning this here. So I'm literally just going to statically assign it in the transformation, which is a helpful and useful thing to do, especially if you're troubleshooting or you're building automations. So in this case, since I want to return a string, I'm going to my string methods and I'm creating a new, a new string here right at the top, and I'm just defining it. Loopback 389. So this loopback address does not exist, okay? And because we're gonna use that later to do some testing in our evaluation portions, but this doesn't exist. But I want to on the router, but I want to leverage this here. So now I'm also outputting this. So when this transformation runs, it's going to extract the information from NetBox that we need, give us just the IP address, and then it's also in the same data that it returns, it's going to give us the appropriate loopback interface to use, or the new interface to use for the automation. So that's what that does. So once you've built that, you can actually save it, and then from within here, you can actually run some tests, because we use live information from that subsequent call to NetBox, it actually saves all of that information when it generates the schema, that when we inferred the schema, as example data. So it allows us to do a run from here and test that our logic is correct and we're getting the right information. So indeed, The IP that was returned from our example data is now without the /24, and the interface is loopback 389, which is what I defined here. A little bit later, I'll do this. I'll change it to the 301 because that is an interface that does exist. And so if I run it here, you can see that now the interface changed back to loopback 301 because I statically defined it. If I change it back, we can run our test again. And this is a great way to test that your transformation is working as you intend it to work. So now let's go back, since our transformation is built and we've stepped through it. And now let's replace this particular task. So if I do a search for transformation, that's part of, this is another task in our workflow palette here, or our task canvas. So this allows us to now run the transformation. So we created the transformation that now exists on the left side, but now we can execute it and run it by using this transformation task. So just like I did before, I can put this in here. I create the transitions between these tasks. So now it's inserted into there. Now we double click it and we need to fill out any kind of required variables here. So we'll give it a name here, extract IP and interface. Now the next thing it's going to ask me is what's the transformation name. I can go back here real quick. I named this webinar DG get IP. So if I go webinar DG get IP, now it's saying, okay, you've defined an incoming schema. So remember that was the schema that we created on the left hand side. So that's the data it expects to receive in that particular format, and that's the output of the NetBox call we did in the first step. So where does that data come from? It comes from the NetBox call. So what the NetBox call is called get IP address. That's that task right before it. So now I can access the data, the outgoing data from that task, and now make it the incoming data for our transformation task. It returns a result value, and that's the data that we need. And so now our transformation will parse that data out. So if I save this, we can do another run. And so now we view the job, we go into our job manager, which shows us what's happening step by step. And we're going to focus on here because, again, these are the two tasks that we've just updated. We've taken the stubs out and we're putting live calls into them now. From here, you can actually see step by step from the bottom to the top, the path it's taken. So really what we want to do here is take a look at this. So this is our transformation task. So recall that coming out of here, well, let's go here first. So coming out of here, so this is our NetBox call. We should have gotten a new unique IP address. That's why I'm using a test prefix, because we're burning a lot of IPs through our testing. But that's what you do when you start to build and test and iterate. Notice that we now got the IP address of 10.1.1.16. So now our transformation should have received that as the input and output what we wanted, what we defined. So now let's go back to our transformation task. We can take a look at the incoming data. The incoming data was from NetBox, and again, that 10.1.1.16 is there. And now the result of the transformation, once it's executed, is it's given us 10.1.1.16 without the /24 and the statically assigned interface, which is loopback 389. So now that data can now be used later on in these workflows. So so this is an example of leveraging an API called a NetBox, extracting the data. So we've gathered that data, and now we've extracted what we need from it through a transformation. This, again, we're keeping it simple here. We could have multiple calls to multiple systems if the data we need in order to deploy change and even check the environment, the state of the network before we make the change and after we make the change. We could gather data from a number of systems, doing a number of API calls, feeding that data into the same transformation, and then extracting the data that is necessary so that it can be used on the output for any number of these calls. And that's part of the data gathering process for accessing API systems. It's critically important because the more systems that you're gathering data from that you're not automating, you're swivel chairing, you're copying, you're pasting, you're putting it in a notepad or text editor or Sublime. We want to automate that process because it's a huge amount of time for that. So that's how you can do API calls and gather data from API calls. But what about network state? What if we want to gather data from a CLI device and gather data about network state? So now let's talk about this pre-check. That's what we're going to do here. Does the interface exist? So now we have the information basically to configure the interface, but as our pre-check, we need to ask the router, does this interface even exist? So that's where we're going to use command templates. So let me show you a command template. So again, a command template is a feature on the left-hand side here. You can create a new command template. It will appear here, very similar to a transformation. When we do a command template, this now start to look very familiar to a network engineer. A command template allows you to type in commands just from the CLI, right? So this is a CLI focused tool in our platform. In this case, I'm going to do a show interface, but I'm creating a variable called interface because that comes from our transformation that we just built and inserted into the workflow. So now this can be reused across many different, like many of these tools and features, the idea is for it to be reusable. So we can insert a variable and have the interface passed to the command template, so it can use that interface name, and it can be used across a number of different routers and different interfaces. In this case, I just want to show the interface and the specific interface. And what command templates do is not only do they execute the command, they capture the output, and then they allow you to build a rule to determine if that output matches a certain condition. So in this case, I want to match the condition that it doesn't contain. So that's what the exclamation point in front of the contains means. Doesn't contain. That interface is up and the line protocol is up. Because what we're doing is, before I make a change to create a new interface, that same interface shouldn't exist, right? And now you might have a number of things that you do for a particular change in the network. This is where you start to define those, and this is where you start to create those rules. So what are the commands? What is the output that I typically need to parse manually, maybe even copy and paste somewhere? And what am I checking for, right? What am I looking for? So in this case, I shouldn't see this. If I see that interface is up, that means it's already in use, and we should evaluate that and not make that change. That could be a dangerous change, right? So that's what's going on here, and we can test it here. Since we have access to a federated inventory of devices, network devices on the network, and actually network services. They could be API managed network services as well. I can access a device in our lab here that's onboarded into the system, and then I can test this command. So when I click that, it's going to say, hey, what's the interface name? So if I give it a interface name of an interface that doesn't exist, right? So I'm sorry, 389 is the one that doesn't exist. 301 is the one that does exist. Click submit. And now it's going to execute this command right now on that device, give us our output back. So you notice here, our output, this was the interface, show interface. It replaced the interface variable with loopback 389, because that's what I passed to it when we did the test. And now it executes that, and the result was I got invalid data. You could also do a rule that contains something specific here, like invalid input detected. But it makes it simple because now everybody knows what you're looking for. When somebody else is, like, if you're building this, somebody else looks at it and says, oh, they're looking for the state of it being up. So we can tell now, hey, this is this interface doesn't exist, right? So that's a good thing. So what we want to do is this rule came back as passed. That interface doesn't contain that, so therefore it's not up. And this is what we're really going to be looking for in our workflow. We want to evaluate the output of this command template, right? So we're gathering data from a network device using CLI. Now, instead of parsing it manually with our eyeballs to determine if everything looks good, we can now take that knowledge in our mind and express it here as a series of commands and a series of rules of what to look for. And ultimately, we can say all these commands must pass, or you can actually define one command must pass. But usually it's all commands must pass, and that sets the stage for saying, okay, now the pre-check is good. Now we're in a state where it's okay to make the network change and do it in an automated way. So that's what we're doing here. If I run this again and I give it an interface that already exists on this router, loopback 301, it should fail because it can't contain the fact that it's up, and that's exactly what it does here. So it ran the command. It told us, hey, loopback 301 is up. The line protocol is up. It's got a working IP address on it. We've just detected that in our test here in our command template, and so now that's exactly what we want to see. So now we have the ability to determine the network state based off of the commands that were executed and the rules that we defined. So that's a pre-check. Now, a lot of times when you create a pre-check condition, a set of pre-check conditions, you also want to do a post-check condition, which looks for the same things, but maybe the rules are slightly different. So it may have the same commands, but the rules are slightly different. Maybe they're inverted a bit. So what do we mean by that? Let me show you this. So this looks very similar, but this is our post-check for the interface. The same command, show interface, and then we variabilize the interface name so we can pass that in as a variable. But instead of doesn't contain, now we're looking for it to contain, right? So now we've inverted the test, because if you think about it, when we first run the pre-check, the interface shouldn't exist. So we say the rule should be doesn't contain. Then we make the change so the interface exists. If everything went well, then our post check can come in and say, does this if I do a show interface on that loopback interface, it should contain this information, right? And if so, that means at least from the state of the router, it's up. We can add more rules, right? Maybe we want to get a little more specific, and this is now where you can start to create multi-layer rules. This again is just CLI, but you could also create multi-layer pre-check and post-check rules that are CLI and API. If you have another system that maybe has some knowledge of the network state, right, and an API available, that can be onboarded, that can be queried in an API call, that could be part of a multi-layered pre-check and post-check process. For here, we can actually do another rule so that we can have a second rule for the same output, and we could take a look at, with the IP address. So we could do something like this. So I can define a variable that we could pass to this that also says for the post check, not only does the interface need to be up, but it needs to contain an IP address as well. And so we can do a quick test on that. And now it's going to ask me for two variables. If I do loopback 301, and I don't know what the IP address is, but fine. Give it something to use as a variable. Now it's going to execute that command, and it should come back and it should give us a state. Okay, the interface is up, so that matched. However, you'll see here the IP address was not the same as what I specified it in my variable. So in this case, the actual IP that's using is this. And so it failed that. Because of that, the entire condition of this process is a fail, because all commands must pass. So if we wanted to see it test successfully, I would have to do this and provide it the right IP address that we expect to be on there. And now when we rerun this, it should now come back as passed. You'll see both parts here are passed, and therefore the entire process passed. So this is exactly what we're talking about. We're gathering data. We're in this particular process of command templates, it's not just executing the command, but it's allowing you to parse this. So this automates that whole process so that when we go back to our workflow, we can run this pre-check process and then evaluate the output of it. Did it pass or did it fail? Because that makes a difference, right? And this is precisely what you're doing when you're making these network changes. You're looking at the condition, you're evaluating it, and then you're determining, should I deploy the change or not? And you're also evaluating after the change is made, does everything look good? Evaluate, yes or no. And so now we'll continue to build upon that. So in order to run this command template, another part of our platform is a task called run command template. Pretty straightforward. So I can bring this into here, and now we can do that. And if I double click it, we can run this command template. What's going to ask us for some variables? What is the template name? That's the first piece. Our template name here was webinar. Well, that's our post. We want to get to our pre-check interface. So I can grab it from here. Go back put it into there. So now we're specifying that particular template's what we need to run. For variables, we need to give it, remember we variabilize this, so we need to give it an interface as a variable, and we need to give it an, well, in this case, it's not using an IP. I think it's just using a variable for the pre-check. So what I can do is I can tell it, remember our transformation outputted for after the NetBox call to get the IP address, and it extracted the information we need. We did that so we could pass it to the command template. So what I need to do here is, instead of statically assigning this this object, I can say, hey, that data that you need for your variables comes from that transformation, which was called webinar DG get IP. And then the value that it returns is called to command template, which I defined. And here, I just, because we want to keep it simple, again, this could have been information we could have gotten from another system. Instead, I'm going to just to statically assign this. This is the devices. So what is the network device that we want to execute this template on, right? And I use, when we did a test, I pulled it up from our inventory on the system. But in this case, I'm going to statically assign it. It looks like this because it's asking for an array. So this is the format for an array. We could have multiple devices since it's asking for array. In this case, I just want a single device. So now I can save that. And there's one change I do want to make here. Just to keep it simple, I'm going to delete the IP address. That was just as an example to show we could do a multi-layered or multi-tiered, multi-layered or multi-tiered pre-check and post-check using command templates. Okay, so we've defined that. So that's good. So we can also do the same thing here. So I can take a little bit of shortcut here and copy this task and bring it into here, because I want to replace the post-check as well with running this command template. So we give it a specific name, pre-check. Check. And now the template's going to change because we're not running the same template. I've got the post-check template, which is similar to pre-check, but it's not the same. Remember, we're changing to contain is interface up and line protocol up. And again, variables can again come from our transformation, because that was the whole point of the transformation, to extract what we need it to pass to our command template. And I'm going to keep the device the same here. So now if I save this, we should be able to run it and then track our progress through everything. So we'll run it as a test. We will end up going through, you notice it went through here pretty quick. It went through our pre-check process. So let's just take a look at this. The data that it gave us, this is what we sent to it. So it got an IP address from our transformation. This is the device it executed on. And the outgoing data here is we're looking for results. So we want to know what the result is. Remember, that's the overall result. Was it a pass? Was it a fail? So in this case, it used interface loopback 389. That came from our transformation. And because that loopback interface doesn't exist, it doesn't contain this line of is it up. So therefore, it passed. So the result was true. Now let's take a look at our post check. Again, it got the same information because it's using the data from the same transformation. But on the outgoing, this is false. Why? Because in this case, we were testing it to see if we expect it to be up, because the network change should have made it up. But in this case, it did not pass. And because of that, because it did not match this rule, it's not up. It's still down because we didn't actually make a network change. But we're seeing that we can now gather the data and see the evaluations as we're building this automation to determine whether it's okay to progress or it's not okay to progress. So really, the last thing we need now is to update these evaluations, and then our data gathering for API and CLI really is complete for this particular workflow. So I've already kind of built this out a little bit in a little bit more of a structure here so we can kind of see this. So the last part is, this is exactly what we've just done. We're getting the IP address still. We're doing our transformation. In fact, it's using the same transformation that we've been using here in the last workflow that we built out. So this is gathering data from an API call in NetBox, extracting the data, that we need, and then feeding it again to a pre-check. This is running the same pre-check, and except now I've filled in this evaluation. So an evaluation comes from here again. If you type in eval, it will show you the evaluation. And if I double click the evaluation, what it's asking for is, what are you looking for in the previous results? So the pre-check interface, this is where it runs a command template. So this is the source. I'm saying from this task that just executed, get the results. So this is the variable that holds all the results. And now I want to query specifically something called the result, and I want to compare it to true. And if it's true, then it's going to take our green path of success. But if it doesn't come back as true, it's going to take this red path where it fails. And that's kind of our rollback, or, hey, we need some assistance here. Something didn't match. But we're gathering, the idea here is we're gathering that data, and now we're extracting it and evaluating it all in kind of really two steps. So what is an evaluation? So again, where does this information come from? How do I know to put all this information in here? If I go back to Operations Manager, I take a look at this pre-check task. I look at the outgoing. Let's see. Whoops. I think I closed the other one out. I'll show you in a moment. We'll run it again, and I'll show you in a moment. So that's what it's doing. It's doing a check, and it's looking at this particular value. Result, if it's equal to true, that's our pass condition that was returned from the command template. Then it's going to take this path. And similarly here, the post check, we're going to do the same thing. We're doing another evaluation, except now we're telling it to evaluate the post check. And again, the result needs to be true. So this is that normal process that all of us are manually going through before we make a change to check the situation on the router. Does it look good? Yes, make the change. If it doesn't look good, stop. Maybe something else is up. We need to do some investigation. After you make the change, let's take another snapshot of what everything looks like on the network. In this case, we'll look at the interface again. Is it up? Because it should be. If so, we're good. If not, again, make a stop, halt, and let's take a look at what's going on. So the last thing we can do is we can run this. So the first time this runs through, let's take a look what we've got in our transformation, because remember, we are kind of seeding this interface. So loopback 389 doesn't exist. It doesn't exist. So when I run this pre-check should pass because it doesn't exist, right? But then it should go to the deploy change, which is not actually making the network change, right? So we're actually not focusing on that. We're just trying to check our data gathering and our evaluation. And in this case, since we expect it to be up, the evaluation should say, oh, wait a minute, this is up. That should pass. So it should fail here and pass here. So let's run it. Let's view the job. All right, so now it's doing our command template. It's going through and saying, aha, loopback interface here is the evaluation. So loopback interface 389, which is not up on the router, runs through this command template, and it's true. So here's that result I was showing you in the evaluation. So that evaluation is looking at the output of this and saying, if this variable is set to true, then it passed. Now, what happened? It would have gone down this path here, deploy network change. Since this is a stub still, since we're not actually making a network change just for testing purposes, it's going to go into this evaluation. So in this case, it's going to also compare loopback 389, but it's also going to say failed. Why? Because that interface isn't up, and it's expecting it to be up after a network change. So this is exactly what we expect. So now the evaluation has taken this path, and you see this blue line around it. That means it stopped here at this view data. View data is a manual task, and it just stops the workflow and says, hey, somebody needs to take a look at this. You can pass data to it. In this case, I'm just using it as an example. So if I go to that task and work it, all it's set up to say is the eval failed, that task failed and took this path, which is exactly what we were testing for, right? We gathered the data and did an evaluation. So the last thing we can do is we can take a look at what it looks like when we run the same thing. So I'm updating the transformation, and now because the transformation's been updated with this loopback interface, I'm changing it to an interface that does exist. Let me save this. And so now we're going to seed that information into our workflow again with a different piece of information for the interface. So now we should see a different path. So This is completed, and you can see here, it's harder to see probably in my monitor here, but this grayed out. So it tell when anything in the job manager, when it grays something out, it helps to show you the path that it took. So it did an evaluation this way, passed, went through this way, failed, and then went to end. So we should see the inverse of that now when we run it, because we're changing the interface that it's running, or it's evaluating. So let's go back. We've run this. Let's go back to our job manager. You see this running. It's running the command template. It's hit us on the view data. So let's take a look at some of this information. So remember this eval coming out of here should be, so in this case, last time it was true, now it's false, because we've seeded it with a new interface that exists. It shouldn't exist as a pre-check condition. So now on this eval, it should have gone straight over to here to this view data, because it's not a pass, it's a fail. So it's not a success. It goes down this route. So now it's asking us to take a look at this data. Of course, this is to pause the task. So this view data task will stop it, and we can continue it by working the task and then clicking on continue. And this should progress the workflow. So now you can clearly see the path that it took. It went this way, extracted the data from an API call, refined the data through a transformation to just what we needed, passed that data to our CLI data gathering process in a command template. We were able to evaluate it, determine that the pre-check condition from the data we gathered didn't fit, and so it took a path here where it doesn't make any network changes at all. So this was the inverse of the last one. So as part of testing and gathering data, now then my next step could be to now implement the network change and verify that my data gathering, my pre-check, and my post-check conditions all are operating correctly. So that would be the next step as I start to build out this automation. And with that, I want to thank you. That concludes our demo for today about data gathering. Hopefully this helped you to identify and recognize just how important it is as part of your building out your automations and your automation strategy, just how critical and necessary it is to automate the data gathering process. Normally, you're looking just at automating the deploy network changes, but gathering that data and then manipulating that data, extracting it, and then passing it on so it can be used in other tasks is a critical piece of building efficient automations. And so this is hopefully shows you how to do it on our platform and how much time it can save in your day-to-day workload, especially if you have a tremendous backlog. It will keep you from having to do a lot of swivel chair, a lot of copy and pasting, and a lot of additional work now that can be automated on top of the network changes itself. So with that, thank you very much, and we hope to see you